Okay, we're in the third video in Chapter 7. We're talking about the mole. The mole is the central unit of chemistry. A mole is a unit that describes a number. 6.022 times 10 to the 23rd. That's a huge number. If anything, equals a mole of something. So we can count by moles. A mole we can count individually as counting items, and on 1 mole of anything is Avogadro's number, the number I just described. We can use that relationship between a mole and Avogadro's number to do conversions in and out of the number of something and the moles. So we refer to this conversion factor as Avogadro's number conversion factor. We also know that we can relate 1 mole of anything to the mass of that substance. So if I have a mole of carbon atoms, how much does it weigh? We'll go to the periodic table, 12.01 grams. A mole of sodium atoms, 22.99 grams. A mole of oxygen, 16.00 grams. A mole of hydrogen atoms, 1.01 grams. So we know that we can also relate a mole to how much something weighs. A mole of anything weighs so many grams. And that number will vary depending on what the item is. What we're going to look at in this video, the third video, is not the molar mass of atoms, but the molar mass of compounds. If you have a mole of a certain compound, how much does it weigh? The molar mass of any compound is the sum of the masses of each atom in that compound. All right, now, what do we mean when we mean compound? Just remember that a compound of a pure substance is a combination of the elements that act as a single unit. There's 2 types of compounds that we can have. We can have covalent compounds, are called molecules. So covalent compounds, the smallest unit of that compound is called the molecule. And these are always covalent bonds that occur between nonmetals. So an example is just a nonmetal bonding to a nonmetal, something like CO2. We can also have ionic compounds. And ionic compounds always consist of a metal and a nonmetal. Well, the smallest single unit of an ionic compound, since they're not literally combined, is called a formula unit. A formula unit. I always write F.U. because I don't like writing formula unit out. For example, if you have an ionic compound, it usually contains a metal and a nonmetal, a cation and an anion, technically. An example would be something like sodium chloride. We can't call this the molecule because it's not held together by covalent bonds. But 1 ion of sodium, 1 ion of chloride, that will give us the formula unit of sodium chloride, the smallest unit. The smallest unit of carbon dioxide is 1 carbon and 2 oxygens. Alright, if we want to know the mass of the molecule, or the unit in the compound, or the formula unit, it's just a sum of all the individual masses of the atoms. So let's do an example. Alright, this question says, what is the molar mass of carbon dioxide? Alright, we just did the molar mass of the elements. Elements contain atoms. The molar mass of elements are found on the periodic table. Where are you going to find the molar mass of a compound like carbon dioxide? You're not going to find a number on the periodic table. You're going to find numbers on the periodic table. So let's look at carbon dioxide. We know carbon dioxide consists of 1 mole of carbon atoms and 2 moles of oxygen atoms because it's CO2. If we have 1 molecule of carbon dioxide, it contains 1 atom of carbon and 2 atoms of oxygen. If we have a mole of carbon dioxide atoms, it contains a mole of carbon and 2 moles of oxygen atoms. Alright, so what we're going to do is we're just going to sum up the moles of each atom. Here we have 1 mole of carbon atoms. We know that a mole of carbon weighs 12.01 grams. We have 1 carbon atom. So the total weight of carbon in our sample is 12.01 grams. We also know that we have 2 oxygen moles. We know that from the periodic table, if you look on it, 1 mole of oxygen weighs 16.00 grams. That's its average atomic weight. but we have 2 oxygens. So 16 times 2, we have 32.00 grams of oxygen atoms. So what's the total mass of carbon dioxide? It's the sum of the carbon plus all of the oxygen. 44.01 grams of carbon dioxide. 1 mole of carbon dioxide weighs 44.01 grams. Okay, so let's do a little more difficult problem. It says, what is the molar mass of aluminum carbonate? Al2CO3, 3. Okay, here we have the molar mass of an ionic compound. So the first thing we need to do is we need to find out what the mass of each of the individual atoms are, and then add those atoms together. So first, what kind of atoms do we have? Well, in aluminum carbonate, we have the atom aluminum. We also have the atom carbon. And finally, we have oxygen atoms. So these are the 3 types of atoms that make up aluminum carbonate. What is the mass of each of them? All right. Well, how many atoms of aluminum do we have in the compound? For 1 mole of the compound, we have 2 moles of aluminum atoms. If you go to the periodic table, 1 mole of aluminum is 26.98 grams. So if we have 2, then we have 53.96 grams of aluminum. Okay. What about carbon? How many atoms of carbon do we have? We've got to be careful here, because we have one atom in a carbonate, but we have 3 carbonates. So we actually have 3 atoms of carbon. We know that each mole of carbon weighs 12.01 grams. So if we have 3 moles of carbon atoms, 12, 24, 36, we have 36.03 grams of carbon in our entire sample. And then finally, oxygen. How many moles of oxygen atoms do we have? Well, we have 3 times 3. We have 9 moles of oxygen atoms. Each oxygen weighs 16. It's one of my favorite numbers to multiply here. 9 times 16, the same thing as 12 times 12, it's 144. All right, so here we know that we have 54 grams of aluminum roughly, about 36 grams of carbon, 144 grams of oxygen. If we add all of those individual masses of the moles of atoms together, we'll come up with the molar mass of the compound. You should get 233.99 grams. This is the molar mass of aluminum carbonate. I'm going to challenge you to do the next 2 on your own, so you could pause it and try them out. I'll tell you the answer, so you might want to try them out now. But what is the molar mass of ammonium phosphate? The mass that you should get is D. And what is the molar mass of magnesium perchlorate? Well, the answer you should get is C. So try those on your own. It's okay even if you know the answer, you can still try them, because you need to be able to get these numbers. Sometimes the complex ionic compounds where you have multiple of each type of polyatomic anion, getting the numbers of atoms correct and then multiplying those correctly to get the weight of each atom and then adding them together, sometimes there's math errors. So just make sure you can do that and try those out on your own. Alright, so now we're just going to do some more conversion problems using Avogadro's number and molar mass. But now we know that we can use molar mass, the grams per mole, of not only elements on the periodic table, but we can come up with the molar mass if we combine all of the molar masses of the atoms to get the molar mass of the compound. So now we can do conversions of amounts of molecules to moles to grams for compounds as well as atoms or elements. So we'll be using molar mass and Avogadro's number to calculate each of the following problems. So let's look at the first one. The first problem here says, calculate the mass, so how many grams am I going to have, of 150 moles of magnesium perchlorate. Now, in the previous problem we just did, I asked you to calculate the molar mass of magnesium perchlorate. So we're not going to literally calculate that again. I think you should be able to calculate that. But the molar mass of magnesium perchlorate is 223.21 grams per mole. Anytime you ever see the unit grams per mole beside a number, you know that you're given the molar mass. It's the mass per mole, or the molar mass of that compound. That's a conversion factor that you're going to use to help solve this problem. Many times, like on an exam or in a homework assignment, you'll see that I'll give you that number. I'll give you the molar mass, but I want you to do the conversion. Sometimes, though, I won't give you the molar mass, but you should be able to know if I'm going to do a mass to moles calculation, you should know where that number comes from, which is what we just talked about. Alright, so this one says calculate the mass from this many moles. Now remember, what's the central unit in chemistry? A mole. So can I convert moles to mass or mass to moles? Yes, I can do that in one conversion factor. The conversion factor is moles, or molar mass. So here I'm given moles. I want to calculate the mass. I'm going to use that molar mass conversion factor that we just talked about. So let's set it up. We always start with what we're given. We're given 0.150 moles of magnesium perchlorate. I want to convert my moles to mass. So I've got a mole on top. I'm going to put my mole on bottom. I always put my units together first when I do my conversion factors. So I've got a mole on bottom. What goes on top? Well, mass. This is the molar mass. So 1 mole of what? Magnesium perchlorate is how many grams? Well, it's given to us this time. It's 223.21 grams. Alright, so now I just multiply. If I have 0.15 of a mole, then I have 0.15 of the grams that it weighs. So what's 0.150 times 223.21? My unit left is a gram. I get 33.5 grams. That's how much that many moles of magnesium perchlorate weigh. Notice once again, 3 significant figures, because what did I start with? 3 significant figures. Remember that zeros in the front never count. The zeros at the end with the decimal or pins, that 0 counts. So I've got 3 significant figures to start with. I end with 3. Alright, let's do another one. Alright, then this question says, calculate the number of moles in 35 grams of water. So we know water is a molecule, so we're given grams of a molecule, and we want to know how many moles that is. Let's do a solution map. Let's start with what we're given. We're given mass, and we're asked to calculate moles. Is there any conversion factor you know of to get from mass to moles? Yeah, molar mass. Molar mass is, if it's an element, it's found on the periodic table. If it's a compound, you calculate it. So let's figure out the molar mass of water real quick. Water has 2 hydrogens and 1 oxygen. How much does each hydrogen weigh? The molar mass of hydrogen is 1.01 grams per mole. I have 2 of them, so it'll be 2.02. And how much does 1 mole of oxygen weigh? It weighs 16.00 grams per mole. So when I add the weights of my 2 hydrogens and my oxygen together, the molar mass of water will be 18.02 grams for every 1 mole of that compound. All right. That was basically something that you typically don't have to write this out. I think that students are really good at molar masses. As soon as you teach them that you add all the atoms and the number of each together, they'll whip out their calculator. They'll calculate molar mass very, very quickly. But 18.02, we'll need that. So I'm going to write that down over here. And notice molar mass is grams per mole. Anytime you have 2 units, you pretty much have a conversion factor. So that's our conversion factor. Now let's start solving the problem. We write down what we're given. We're given 35 grams of water. Okay, we want to convert that to moles. So I've got a grams on top. I'm going to put my grams of water on bottom. That means I'm going to put my mole of water on top. So 1 mole of water, how many grams is it? 18.02. Alright, so this time I'm dividing. 35 divided by 18.02. It's going to be about 2, isn't it? When you divide that on your calculator, remember we start with 2 significant figures, so we're going to end with 2 significant figures. I get 1.9 moles. If you have almost twice the weight of a mole of water, then you have almost twice the amount of moles of water. Alright, let's do the next one. It says calculate the number of molecules in 35 grams of water. We're going to start all over as if we haven't seen this problem before. Before we just were given 35 grams of water. And what were we asked to calculate? We were asked to go from grams to moles. This time we're asked to go from grams all the way to molecules. Can we go straight from grams to molecules with one conversion factor? The answer is no. Remember, you always go through the mole. It's the central unit in chemistry for conversions. So we're going to calculate grams to molecules, and we always go through the central unit of conversions, the mole. So we're going to have 2 conversion factors here. We have to go through the mole, so we're going to go from mass to moles first. We're going to use molar mass of water. And we've already calculated that up here. And from there, we're going to go from moles of water to molecules of water. The number of molecules in a mole is Avogadro's number. And that number never changes. So let's go ahead and calculate it. We're going to go from grams to moles first using the molar mass of water. This is actually what we did last time. But let's just look at it again. We've got 35 grams of water. We're going to go from grams to moles. Always go through the mole. So we've got a gram on top, gram on bottom. The molar mass of water is 18.02. There's 18.02 grams per every mole of water. But we're asked to calculate the molecules. So now we say, okay, I know that for every 1 mole of anything, got a mole on top, a mole on bottom, there is 6.022 times 10 to the 23rd of anything in it. So if we're talking about a mole of water, there's 6.022 times 10 to the 23rd molecules of water in that mole. Alright, so let's calculate it out. Here this time we have 35 times Avogadro's number. You can do all that together, hit enter. I would always do the numerator first. Now we're going to divide by the denominator's total, 18.02. The answer I get, notice there's 2 significant figures to start with over here. So we need 2 significant figures here. The answer I get is 1.1 times 10 to the 24th molecules. Now does that make sense? Yeah. 10 to the 24th is more than a mole. If we start with 35 grams of water, water weighs 18 per mole. So we have almost 2 moles. So 6 times 6 is 12, 1.1 times 10 to the 24th. Almost have that amount. Always try to make sure your answer makes sense. Okay, now there are several problems I could do. This is just basically the same thing over and over again. Every time that you do a conversion factor, from any unit, you're always going to use the conversion factor through the mole. So you can do mass to moles, number of molecules or atoms or formula units to moles. The central unit's always going to be the mole. So far we've learned Avogadro's number, we've learned molar mass, converting in and out of the mole to get from one quantity to another of a compound. So here's some extra examples. Go ahead and press pause if you don't want the answers. So you can work these out. And when you work them out, hopefully you'll get the right answer. If not, something went wrong somewhere. The answer for the one up above, how many molecules in 146 grams of glucose? The answer here is going to be B. So you should get B. Right? If you didn't, you're doing something wrong. Let's go to the next one. What is the mass of 1.02 times 10 to the 30 molecules of methanol? So you're given molecules, you want to calculate mass. You're going to have to go through the mole on that one. You're going to go from molecules to moles to mass. So you're going to have two conversion factors. Okay? Avogadro's number and molar mass for methanol. Your answer there should be D. So check and make sure you get D. And the final one's not multiple choice, so it's a little more challenging. But it said how many molecules are present in 4.21 moles of HBr. The reason it's more challenging is because you don't have answers. What I always find is if you have answers, sometimes you feel a level of comfort. But if you don't have the answers given like on a test, you feel uncomfortable about what the answer should be. But it's the same thing we've been doing. You're given the moles of HBr, you're going to calculate the number of molecules. If you're given moles and you want to go to number of molecules, you always use Avogadro's number. So that'll be you're only going to have one conversion factor this time. The answer for this one will be 2.54 times 10 to the 24th molecules of HBr. So go ahead and work those extra. You can never work enough problems, especially in chapters 7 and 9, 7, 8, and 9. So go ahead and work those, see if you get those answers.